Hi, welcome to our channel Master of Science.
Hi, in this video we are going to discussing about the method of mixtures. So in this method of mixtures we have just examined the three situations. The situations are situation 1 and situation 2 and the situation 3. Three situations we can observe clearly. So we can take two beakers of same size and take 200 ml of water in each beaker. Take 200 ml of water in each beaker and heat the two beakers until it attains the same temperature. Same temperature means maybe this beaker how much of temperature? It is also same temperature. For example, the temperature is 90 degrees centigrade and this is also 90 degrees centigrade. And after that, the water in the beaker are pouring into one large beaker. So once pouring this all water into this large beaker, what is the mass of the water here? Almost it is a 400 ml of water. And then what is the final temperature? What is the final temperature? So same mass and same temperature. So that reason the final temperature also almost 90 degrees centigrade only. And coming to situation 2, here also we can take two beakers. In one beaker 200 ml of water and the another beaker also same 200 ml of water, and this is heat up to 90 degrees centigrade and this is up to 60 degree centigrade, and this water is also pouring into the one large beaker. This is also pouring into one large beaker. This is also 400 ml of water. Then what is the final temperature? Generally same amount of water, so that reason 90 plus 60, 150. 150 by 2 is nothing but nearly it is a 75 degrees centigrade of temperature. We can assume that. And the situation 3 is, here also we can take two beakers. But in the first beaker you can take only 100 ml of water and it is heat up to 90 degrees centigrade. And the second beaker you can take 200 ml of water and this is reaches to 60 degrees centigrade only. And again these two beakers of water is pouring into one large beaker. And this is a 300 ml of water. And what is the temperature? What is the temperature in the third situation? So here only 300 because 100 ml of water is at 90 degrees centigrade and 200 ml of water at 60 degrees centigrade, and these two beakers of water is again pouring into the large beaker. Now find out the temperature. So in the third situation we can't say without thermometer. So in the first situation by using thermometer we can find out the temperature, and situation 2 as well as situation 3 by using the thermometer we can find out the temperature, but without the thermometer also we can find the temperature by using one formula. Now we are going to derive that formula. For the derivation of that formula we take one example. That is, we can take one beaker. In this 200 ml of water is there and it is reaches to 90 degrees centigrade of temperature, and you can take one more beaker. This is also 200 ml of water and it is at 60 degrees centigrade of temperature only. So this mass is taken as a M1 and this mass is taken as M2. This temperature is taken as a T1 and the temperature is taken as a T2, and these 2 beakers of water is again pouring into one large beaker. So the final temperature of the mixture is taken as T. So these are the notations. This is M1, M2, and the highest temperature is taken as a T1, and this is the lowest temperature is taken as T2, and the mixture temperature is taken as T. Now we can find out the final temperature. That is the formula, final temperature formula. So always we can remember one point. That point is final temperature is always lower than the temperature of the hotter sample, and final temperature is always higher than the temperature of the lower sample. That is colder sample. So final temperature is always lower than the temperature of the hotter sample, and final temperature is always higher than the temperature of the colder sample. So you can remember that point. This means that hot sample lost the heat and cold sample gains the heat. So hot sample lost the heat is equal to the cold sample gains the heat. So you know the formula, Q is equal to Sm delta T. By using the formula, we can find out the how much of heat lost by the hotter sample and how much of heat gained by the colder sample. So first one is heat lost by hotter sample. This is taken as Q1. So you know that Q is equal to Sm delta T. So S is specific heat. We can take both beakers water only. So the reason S is written as same S, and then M1 and delta T. So change in temperature. Hotter sample means T1. Final temperature means T. So change means T1 minus T. T1 minus T. Why you can write here like that? Definitely T1 temperature is more than the final temperature. Just before you can say that mixture temperature is always lower than the temperature of the hotter sample. So T1 is the temperature of hotter sample and T is the temperature of the mixture. So the heat lost by the hotter sample Q1 is equal to Sm1 T1 minus T. And the second is heat gained by the colder sample. Heat gained by the colder sample is taken as Q2. So this is written as Sm2, and final temperature, it's nothing but mixture temperature is always higher than the temperature of the colder sample. So the reason here you can find out the T minus T2. Then only you can find out the difference. So these are the equations: heat lost by the hotter sample Q1 as well as heat gained by the colder sample Q2. We can get two equations. So that is nothing but heat gained by the colder sample as well as heat lost by the hotter sample. These two are equal only. So this is written as Q1 is equal to Q2. Why you can write Q1 is equal to Q2? Heat lost by the hot sample is equal to the heat gained by the colder sample. So that reason we can write we can write it as Q1 is equal to Q2. So we can equate these two equations. That is Sm1 T1 minus T is equal to Sm2 T minus T2. So we can cancel the S and S here, and now we can multiply M1 T1 minus M1 T is equal to M2 T minus M2 T2. So we are going to discussing about the final temperature. So we need a T. So the reason this minus M2 T comes to this side, it becomes plus. So M1 T1 plus M2 T2, and this minus M1 T goes to that side, it makes it also becomes plus M1 T plus M2 T. So here we can take the T as a common, M1 plus M2 and T, and here M1 T1 plus M2 T2. So finally we can write the formula, that is T is equal to, this M1 plus M2 comes to this side, it is divides, because in this side it is multiplied. So M1 plus M2 comes to this side, it is divides this equation. So M1 T1 plus M2 T2 by M1 plus M2. This is the final temperature formula. Final temperature formula T is equal to M1 T1 plus M2 T2 by M1 plus M2. Now we can define the principle of method of mixtures. When two or more bodies at different temperatures brought into thermal contact, net heat lost by the hot body is equal to net heat gained by the cold bodies until they attain the thermal equilibrium. That means net heat lost is equal to the net heat gain. Net heat lost is equal to net heat gain. This is known as a principle of method of mixtures. Okay. If you like this video, please like, share and subscribe the video. Thank you.